This question says, for the quadratic function f of x equals x squared plus 4x minus 12, answer the following parts. Does the graph f open up or down? So a quadratic function will be of the form f of x equals ax squared plus bx plus c. This is the general form of a quadratic, which is what we have. If you want to know whether a quadratic will open up meaning that the parabola is shaped like this, or opens down, meaning like this. If you want to know whether the parabola opens up or down, you're going to look at the value of a. So the value of a for our function is 1. So whenever a is positive, the graph will open up, and whenever a is negative, the graph will open down. So because Ra, the coefficient of the x squared term, is positive, our graph will open up. The next thing we want to focus on is what are the coordinates of the vertex. With a quadratic function that is in general form like this one is, we have two avenues to find the vertex. We can use a process called completing the square to manipulate that general form and put it into vertex form, and we can find the vertex that way, or we can use a vertex formula. So let's take a look at that. So if we were going to use completing the square, I would take my function f of x equals x squared plus 4x minus 12, and I would group the two x terms together and sort of write the minus 12 on the side. And we want to come up with what we might say is a magic number. This magic number is going to complete the square. It's going to make the expression factor into a perfect square, and then it will be in our vertex form. So what we do is we start with the coefficient of the x term. Well, let me back up a little bit. First, you want to make sure that you have a 1 in front of the x squared term. If you don't have a 1 already, you're going to factor out whatever that coefficient is. Since we have a coefficient of 1, we get to ignore that part and jump to this next part, where we take that number 4, we divide it by 2, and square it. 4 divided by 2 is 2, 2 squared is 4, so our magic number is 4. We're going to add that magic number here, but we need to balance our equation by also subtracting that amount over here. So now inside the parentheses, we have a quadratic expression that will factor to x and x, 2 and 2, the plus and a plus. We can combine those terms of minus 12 and minus 4 to become minus 16, and then we have x plus 2 squared minus 16. So we've taken that quadratic function in general form and now written it in vertex form, and the vertex form looks like this: f of x equals x minus h squared plus k, where hk is the vertex. So based on that, we can see what our h and k are. Our vertex is -2, -16. So we have the vertex, but I mentioned there was another way to find the vertex. You can use the vertex formula. And the vertex formula you can find the value of h, the x-coordinate of the vertex, by this formula, -b over 2a. So for our for our function, we already mentioned that a is 1, b is attached to the linear term, so b is 4, and c is our constant, which is negative 12. So for us, h is negative 4 over 2 times 1. That's negative 4 over 2, which is negative 2, just like we got over here. So we got the same x-coordinate. The way we get the y-coordinate, there is a formula for it, but I prefer just to take this x-coordinate and plug it into our function to get the y. So that would be negative 2 squared plus 4 times negative 2 minus 12. Negative 2 squared is a positive 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. And negative 4 minus 12 is negative 16. So you can see we got the same y-coordinate of the vertex that we got with completing the square. So our vertex is negative 2, negative 16. The next part over here says, what is the equation of the axis of symmetry? So these parabolas have symmetry, and if we take a look at a sketch here, the symmetry happens when you pass through the vertex of that parabola. So you're going to have a symmetry, a mirror image on both sides of that vertex. And so we use a vertical line. So I've drawn a vertical line, that dashed line. And the equation of a vertical line is x equals. And since it passes through the vertex, we're going to use the x-coordinate of the vertex, h. So x equals negative 2 is the axis of symmetry for this example. In the next part, we want to find any x-intercepts. So to find x-intercepts, we let y equal 0, and f of x is the same thing as y. So I'm going to set my function equal to 0 and solve. This one can be solved, let's see if we can solve it by factoring. So 12 is 6 times 2, and we could use a positive 6 and a negative 2. Okay, so that's the correct factorization. We would set each factor equal to 0 using the zero product property. Get x equals negative 6 and x equals 2. So those are our x-intercepts. To find a y-intercept, that's the next part here. What is the y-intercept? We're going to let x equal 0. So let's calculate f of 0. 0 squared plus 4 times 0 minus 12 is negative 12. So negative 12 is our y-intercept. Next, I'm going to draw the graph. So we have now found that we have a vertex at negative 2, negative 16. And what I'm going to do is sort of adjust my picture just a little bit because I can see that my vertex is a little bit lower than I need it. So if I continue this down, that would be negative 13, 14, 15, 16. So negative 2, 16 is where the vertex would be. Then we have x-intercepts at negative 6 and positive 2. We have a y-intercept at negative 12. And we know we have a parabola that opens up. So right at this vertex here, I'm going to have a parabola that cups up or opens up. So this is a sketch of the graph. Now to find the domain of every quadratic will be negative infinity to infinity, or all real numbers. There are no restrictions on substituting into a quadratic function. However, the range, we notice, I'll use my ruler here, range are the y values if I go from bottom to top. The first time my ruler would hit the graph would be at the vertex, and then it would continue on to infinity. So in general, we're going to go from k to infinity for any up-facing parabola. For this example, our k is negative 16. So negative 16 to infinity, and with a bracket on that negative 16. Finally, we want to determine where the function is increasing and where it's decreasing. So if I trace this graph going from the left to right, I can see that the y values are decreasing along this section and then increasing along this section. So that section is marked off where the vertex is. So negative 2 is going to be kind of my mark where it changes. So I'm going to say that this function is decreasing from negative infinity to negative 2. And some definitions for increasing and decreasing will use a parenthesis here, and others will use a bracket. So just pay attention to the wording of the definition. What you're looking for is if it says open interval, you're going to use this way. Interval in general or closed interval would be the other way. For increasing, this graph or function would be increasing from negative 2 to infinity. And like I said before, you might need to use a bracket depending on the wording of the definition. Thank you for checking out my videos. Have a great day.